We are now live.
Yes. Okay, let's start. I'm Lee Yi. I'm the community lead. You should have seen me in some of the events. I deal with community outreach. This is Jean.
Yes, I'm an engineer with AI Singapore, and I actually have a degree in biology. So I was very much self-taught with data science, like a lot of you guys. Definitely excited for the journey that you're on.
And I'm Jen. I just did my PhD in environmental engineering, and now I'm an apprentice in the AIAP program.
Okay, now that you know all our names, let's get started with an admin brief at the start, because I know that we've received a lot of feedback and questions, so I just want to go through everything. So let's go. Okay, welcome to our AI for Industry First Ask Me Anything. Yeah, for the first part, we'll be going through, we'll be going through the ground rules from AMA. So firstly, be positive, be polite. We don't want anyone to be too disruptive. Ask relevant technical questions. And for the first run, I know a lot of people are saying that the Zoom, they're having difficulties with the Zoom. So let's start with a YouTube Live first. It's easier to access. And in subsequent runs, we'll be using the Zoom platform for all our AMAs. Okay, we'll run through the how to use Zoom in the subsequent slide, so just stay tuned for it. Yeah, okay. Now, there are a lot of confusion for the completion criteria. So let me just go through the 3 completion criteria that you need to fulfill to complete this program. The first one is that you need to fulfill 75% of the face-to-face workshop. The first one of which is was on 8 November, the introduction to AI, and the replacement workshop will be on 12 Jan. The next one will be on hands-on machine learning. It's 18 or 26 Jan. So bear in mind that you only need to attend one session of the workshop. Okay, one session, not both, just one. And the second criteria is that you need to complete the data scientist with Python career track. Complete all the modules and achieve 75% of the XP. So it's 783, sorry, yeah. If you're unable to fulfill the 75% XP on the data scientist career track, don't worry. You can complete an additional DataCamp project to fulfill, to score the XP to achieve that 75% XP. Okay? Okay, for next is the SITREP claim. I know all of y'all are very concerned about the SITREP. Just note that for now, you only need to verify your information on the SITREP accounts, the IMDA accounts. You only need to do a visual verification. Just need to see that your information is correct on the system. And you should only process your claim after the program. I know some of you guys have already submitted your claim. Just drop SITREP a note. I think the email address is sitrep@imda.gov.sg. Just drop them a note to tell them that, oh, I've already submitted a claim, but just ignore that claim and you submit a claim afterwards. And the next thing is that for DataCamp access, all of you guys should already have it. We've invited everyone and cross-checked it. So if you haven't received your invitation email, fret not, you should have premium access already. Just go in and just try and log into any of the premium modules. And if you're not able to access them, then drop us an email. Okay, so yeah, looking at the live chat, I see that some of you guys are asking whether the 75% attendance is required for AMA. So just to be clear, the 75% is only for the workshop, Introduction to AI, and hands-on machine learning. So this 2 right here. AMAs are not required. We won't be taking attendance, but it's good that you show up so you can ask questions in real time. Okay, moving on. Now we're going to go through how we log into Zoom. So register for an account on Zoom. Yeah, you should go to zoom.us. Link is over at the top. So you log in, click on sign up. If you haven't already done so, you just key in your email and you should receive a confirmation email that looks like this. Activate your account and it will bring you to a website like this. Fill in your details plus your password, click continue. For the next, you can skip the next step and you should view a page where it shows that your account is successful. So after that, you will receive an email prior to each AMA. We'll probably send it out to you. It should look like zoom.us/link. So you click on that link to join the meeting. And then remember to mute your mic. Remember to mute your mic when you're on the call, and you can ask any questions on the chat like it's happening now. Yep, the email should look something like this, and the link is over here. Okay. Yeah, that's about it for my admin brief. So we'll move on.
All right, everybody. So this is an AMA session, which means we will be tackling your questions. And we also feel that DataCamp has so many great resources, and also there's a lot going on in the industry that would be good to have a discussion about and also to add value to you guys with. So what we're going to do is also to add in some extra segments into this session. One thing that we'd like to do right now is, and also for subsequent weeks, is to actually share some tips and tricks about how to use DataCamp most effectively. We're also going to discuss the DataCamp podcast, which shares lots of stories about how data science is being used in industry right now. So again, if anybody is looking to get into the industry, the podcast is a great resource for you to actually understand and gain exposure to what is going on the ground. Then we will take some of your questions, and if we have time, we're going to share some more useful tools that software engineers and data scientists use on a daily basis to make themselves more effective. So our DataCamp resource for this week are actually the DataCamp cheat sheets. So I have here, you can see this is the DataCamp homepage. And what you want to do to access your cheat sheet is to scroll all the way down to the community tab. You can see under resources, there's community. And when you click on community, then DataCamp. Frozen computer. Okay, community. And we want to access. So you see here we can access cheat sheets, and these cheat sheets are actually a summary of all the useful Python functions within each Python package. So I'm going to scroll down right now, and you can see that there is all the way down here, for example, the package Seaborn. There's a package, this is the cheat sheet for statistical data visualization. You can download it, and you can see from the screen share, it's a little blur, but you can see the gist of it is that it's got all the quick and dirty functions that you will need for quick references. And it's a great resource to have pasted on your wall, because I know I can never remember the exact command for pandas, reading in the pandas data frame or creating a scatter plot. So this is a good resource.
Oh, what do you do when you need like more detailed information on the information here? Like the example is not enough.
Yes, that's a great question, Li Tian. So what you can see here is actually a summary, which is great if you're looking for something that you use really often. But I actually also usually reference both the cheat sheet and the actual package documentation. What's a documentation? Some people will ask. Well, it's actually a user guide to a software library. And you can see that pandas, which is basically supercharged Excel in Python, this is the official user guide to Python. It's got all the functionality that you will ever need. So, for example, you can see here you have everything to do with time series, and I'm going to click on this. And then what is great about the actual documentation is that they also include examples. So, for example, you can see here that if I want to change the frequency of my time series or if my data is not complete, then this is how I would actually do it in Pandas. And it's all here for quick reference. So, in my daily work, I normally use a combination of cheat sheets and the official documentation.
And Stack Overflow sometimes.
Oh, yes, I totally forgot about Stack Overflow. So, yeah, maybe Likian, you want to share a little bit about your experiences with using Stack Overflow and what it is?
Yeah, sure. Sometimes you might find that the documentation might not address a particular question that you have when you're trying to do certain plots or analysis. And the chances are that whatever problem you face, someone else has faced in the past. So Stack Overflow is a website where people post questions about, many things, including programming and data science. And you can go there to look for solutions to your answers. So they usually give, very well-written solutions with example code that you can then modify to suit your own needs.
And looking at the live feed, I see someone has come up with a very helpful suggestion as well. So there's a help brackets function in the DataCamp console that is also super helpful and actually even faster than looking at a cheat sheet. So that is also one thing to consider. And one other thing I would recommend also is that when you become a super expert, you can actually build your own cheat sheet. So sometimes what I like to do is that because there are multiple ways of doing one thing, even within the cheat sheet itself, I just list down my personal favorite way of doing it, and then that is my own cheat sheet. Yeah. So that is an overview of what DataCamp offers for this week. And next week, we will be continuing to share various DataCamp resources that can help you be a better data scientist on DataCamp. And yes, so we now move on to our second segment, which is what we want to talk about with the DataCamp podcast. And so, Liken, you and I were listening to the podcast yesterday.
That's right.
And what was it about?
So the podcast was talking about the difference between fake news and real news detection. They interviewed Mike Temer, and he has built a tool of sorts to help people differentiate between what we consider fake news or misleading news, and what is considered like real news or like so-called proper journalism, for example.
Yeah, and he also explained what deep learning is. He also explained how he uses deep learning to detect the difference between fake news and real news. And he came up with an interesting definition of fake news, I think.
Yeah, so in according to their research, they don't call. It's hard to label news as absolutely real or absolutely fake. What they do is instead is try and look at the intention behind a newspaper article or a blog post, for example. So you have things like satire, you have things like posts that are designed to give your opinion on certain topics or to influence others, or certain times you write posts as sort of like trying to be unbiased. And the differences in how this news is written is what people think of as fake news rather than the absolute truth behind the news itself.
Yes, I think that's a very good point a very good summary that you make, Weekend, because if you actually define fake, you need to teach the machine what fake looks like. And it seems here that Mike has gone with the definition that if something is exaggerated or if something is very polarizing, that is his definition of news that essentially doesn't have integrity.
That's right.
Yep, so we got curious about this fake news detector because fake news has been in the news so much. And so we actually downloaded his extension. You can see it right here. And we chose two sources to compare the extension to. So we tried running the extension on the Straits Times, which I think should be pretty fact-based, I think.
Yeah,
And
we should probably go to a specific article first. Where's my mouse at? Like if you click on like one article, and then it will read specific, and then the extension will read the news specific to that article instead of the whole page. So you can see that this article qualifies quite well as what people think of as journalism. And you can see that from the source, the Straits Times got it off Reuters, and that is generally accepted as a legitimate journalism source or source of news.
And what I like about this extension also is that you can see what else the fake or fact detector is looking at. So you can see at the bottom here, right? It's trying to detect whether or not something is opinion, whether or not something is satire or sensational or agenda driven. And I don't know about you, but when I think about fake news, I don't think in such nuanced ways. I just have this heuristic yes or no, and I think it's great that this extension actually has all these different categories to help me decide.
Yeah, absolutely. And for some people, what's fake would be what I don't think is true.
Yes, that's very true. So this is what the Straits Times is like. I think we have another website that
So
we can run.
let's visit some of the more alternative media sources. Choose an article here. How about this one? Oh no. Okay. Just choose a random article on Mothership. Oops. Wrong. And you can see the difference in maybe not the content, but the writing style of Mothership as compared to Straits Times. So this AI, obviously it's not perfect, but it thinks that this article is more opinionated and sensational as opposed to the Straits Times article just now.
Yeah, so it's interesting how this seems to be a very nuanced sentiment detector, so to speak.
Yeah, absolutely. And it's important to note that this is more in the style of writing rather than the absolute incident, whether it occurred or not. So it's important to always get many sources and many different places to get your facts.
Yeah, that's very true. It's not about whether a fact is true or not, but it's more like the way the article presents itself. So one thing that Mike Tamir mentioned, which I thought was really interesting in the podcast, was that he mentioned detecting the difference between satire and non-satire is quite hard, has been always quite hard traditionally. And they've managed to make many good inroads into this with deep learning. However, when you're just looking at whether or not something is super exaggerated or super angry, then he brings up the traditional methods where people just count the frequency of, say, angry words within an article. And he says that just by counting the words within an article to use what's called a bag of words model, then that actually works quite well for the clear cut cases. It's only when you have something like satire that's harder to detect that's where deep learning really shows effectiveness.
Absolutely. And I guess as As these methods become more common, different websites might use new and newer techniques to try and defeat this kind of fake news detectors. And then we'll have to come up with better models in the future to detect fake news.
Oh no, so I may actually have to continuously update my fake news detectors. Right, so I think we mentioned two keywords here that everybody wants to know about, which is deep learning. And I think these two words are mentioned together with AI in many situations, some of them more appropriate than others. And we thought it would be great to also clarify what we're actually talking about. So, Like, what do you think artificial intelligence actually is?
So artificial intelligence refers to an overall philosophy of how we can get machines to make decisions and take actions that normally a human would do.
Normally a human would do. So I have a Roomba at home and it tries to decide where to go in my house to keep it clean. Does that count as an artificial intelligence?
Oh yeah, absolutely. In broad term, your Roomba is absolutely an artificially intelligent machine. It knows when it hits the wall to turn. It knows not to jump off the stairs and commit suicide.
Yes.
It knows how to return to its base. So in broad terms, it is considered an artificial intelligence.
Wow. So it's actually making decisions and taking actions based on signals from the environment. I think of my Roomba as a pet, so I'm actually not that surprised. What about machine learning then?
So machine learning refers more to the implementation of algorithms that convert ideas in artificial intelligence, into the actual products in your computers or your machines. So, it can take knowledge that is not directly taught to the machine and then kind of generalize it and apply it for situations that it may have never seen before.
Yes, so I think I like to shop on Amazon, so I choose a lot of kitchen-based items. And what's similar to baking tools is maybe flour or eggs, but then even though the algorithm has never seen me buy flour or eggs before, it knows I like baking in general. So it will recommend flour and eggs for me to buy.
Yeah, absolutely.
Okay, so then now we come back to deep learning. How does deep learning fit into all of this?
So deep learning is a specific, like more particular form of machine learning where you use things like neural network that uses a lot of computational data and large data sets in order to develop your machine learning technologies.
Right. Okay, so I think now we are actually on to the AMA. And our first question is, what is the proper usage or syntax for lists, strings, tuples, arrays, and data frames?
So let's get technical. So the in Python you will come across four very common classes: lists, strings, tuples, arrays, and data frames. Um, the difference is that for a list, it is basically a sequence of objects. So it would be things that you use your square brackets in. So it can be strings. The members of a list can be strings or integers or any combination of them all. A tuple is basically they identify sort of a relationship between two particular objects. So the difference between things in a list and things in a tuple is that you will not be able to edit things in a tuple. So this will be good for things that you don't want to accidentally change in your code later on by accidentally assigning it some value or another. An array is what a lot of people think of when they think of a matrix. So basically, it is like a spreadsheet. You have data in your spreadsheet, there's rows, there's columns, and because of that, it's easier to make certain mathematical functions. You can multiply arrays with each other, for example, and it'll be like multiplying matrices. And last but not least is the data frame. So the data frame is essentially an array, but it has categories tagged on to each column. So you can reference to things inside the array by by the column name. So when you have a spreadsheet and then the top row is just the name of each column, that will be somewhat like how a data frame functions. And what are the questions? They have a question that says, what is a logarithmic scale? So to put it simply, a normal scale would be, after 1 is 2, after 2 is 3, after 3 is 4. That's considered a linear scale. Logarithmic scale would be everything that will be the power of tens. So, after 1 is 10, after 10 is 100, after 100 is 1000. So it's a good way of compressing data that has a very wide range. Some things that $1, something is $1 million, and you want to have it comparable in a straight line, you will use a logarithmic scale. And you achieve that by doing a log function on every value inside that array or inside that list.
And so then we also have another question, which is the best IDE for Python?
Whoa. I don't want to start any wars here. But if you are using the Anaconda distribution for Python for DataCamp,
yes,
which they do, so you would be using either, you'll probably be using Spider or PyCharm. And I think any IDE works well as long as, it's convenient for you to use. But personally, I use Spider and Python notebooks most of the time.
We have another question, which is something that I think I definitely was confused by. So the one question that we have is when to use a circle and a square bracket. Maybe I can take a stab at this question, and then guys, you can join in if you want to. So the way I see it is that you can use a circle for data structures. Then if you want a tuple, then you would specify that as within 2 brackets. Then if you want to create a list, then you have square brackets. And the difference between these two are that once you specify what a tuple is, you cannot change the values within A and B.
That's right. And someone mentioned also curly brackets, and those are used for dictionaries. So a dictionary is a way to help people, look up stuff. So you would have something like, hey, one, two. So when you run your, code and you're trying to access values from the dictionary, if you type in, dictionary and then square bracket A, you get 1, for example. Someone asked if it's possible to change the base of the logarithm. Yes, it is possible. I think if you do the NumPy log function, you can specify the base which width to change the log. But most people typically use natural logarithm.
Can you explain what unpacking tuples does and where unpacking might apply in future areas? Okay, so I think unpacking a tuple is when you want to unpack data that you've stored, for example. So one thing that may happen is that if your training data is stored in X and your labels are stored in Y, and you want to use X to predict Y. So sometimes when you download the data from sklearn, the data comes as a tuple and it can't be changed. So you want to unpack X into your features. You can say features and then labels equals X, Y. So then now you have features is X and labels is Y. Then you can continue on to work from there, and then that's how you unpack data from the tuple. Is there a difference in using single quotes or double quotes for strings?
Not as far as I know.
Yeah, no, we don't think so. Okay.
And I think Force Master mentioned something quite relevant as well between square brackets and curve brackets, which is that square brackets are used to index elements. So if like you have a variable that is A and you want items 3 to 9, you do square bracket 3:9. Whereas curve brackets are used to give what do you call that? To give input into a particular function. So is to take in a variable and then you run the function and you expand output. So square brackets is to index data. Curve brackets is to give input into a function.
We have one question from yesterday's poll everywhere. So, how different in terms of capability are the more widely used plotting tools like ggplot2, matplotlib, and non-scripting tools like Tableau? I think this is something that we get quite often.
Mm-hmm. Tableau is a very powerful, like all-purpose data plotting tool. But when you are, and I mean, it works very well for most like presentation purposes. But when you're trying to dive deep into the data, you're messing with the code. Sometimes a lot easier just to use Matplotlib just to get a very quick idea of what things look like, and then you can make it beautiful later with Tableau or using other functions within Matplotlib.
And I think it's safe to say that people don't usually use either or. I definitely know people, especially data scientists, who use ggplot2 to do their analysis. Then when they need to present to management or to their peers, then they port their charts or analysis and do it in Tableau to make it look really nice and then present it. So you can definitely use both. And another use case where you might use both is if you want to be very fast with your exploratory data analysis, then you can read your data into Tableau very quickly, check out some connections or interactions, then only start delving deeper with something like Matplotlib or ggplot2. And now we have Lee.
Okay, guys, I know that you guys have a lot of questions, admin questions. I'm looking at the chat right now. Okay, let me just go through one by one. Let's see. Okay, in case you missed the earlier slot, we were just going through the completion criteria, just to note that there's 2 workshops, the introduction to AI and a hands-on machine learning that you need to come for. If you haven't received the welcome email from B-Link that says I think it contains the schedule and just a guide, administrative guide. So drop us an email to tell us that you're unable to locate it. We'll forward it back to you again. Yeah, let's see what other questions we have. Yeah, no attendance taking for AMAs. But we are highly recommended to join us for the AMAs. Just to note that the hands-on machine learning, you'll need your laptops because you'll be doing it's a technical workshop that you need to do practice your coding skills basically. But more information will be sent closer to the dates. If you went for the first workshop and you didn't manage to take your attendance, do drop us an email with the word of the day. We'll take that into account. Yeah, I think I've covered most of them. Okay, we have a technical question here. How big a data set does one need to train an ML or AI system? Do you know the answer to that?
I think to use an example that we talked about before, when people are detecting fake news as a general problem, then if your article is quite clear cut in the sense that it's very sensational and very opinionated, then a simple count of the number of angry words in the article and a simple model will be enough to differentiate a sensational article from a non-sensational article. But if you have something like satire, which is harder, that's when you start to need more sophisticated models. And when you need more sophisticated models, that's where you need more data.
Yeah, really depends on the kind of problem you're trying to solve and how difficult it is for, like, let's say, a human to solve that problem. So certain things can be easily, linearly interpolated. Then you don't need much data for that. But if you're trying to, do things like predict pictures, predict, stock prices, you're gonna need a ton of data.
So, is there a specific quantification? Like, are we talking about gigabytes, or how big is the data do generally? Because I always get this question when I go out. People ask me, so I have big data, but how big should big data be? Do you all know? Is it a subjective question or?
It is pretty subjective. Well, I mean, the rule of thumb is as big as you need to get the answers you want, right? So, you have data sets that are very small that can be like, a few megabytes of data. And then you have, for things like image processing, you need like terabytes of data if you're trying to do like image segmentation or prediction.
Okay.
Why and how often and in which modeling areas industries do people deviate from using out-of-box scikit-learn keras to design custom code?
Maybe you could, before we start answering your question, I'm sure a lot of people are asking what is scikit-learn and what's keras. Can y'all like enlighten us on what does that mean?
Sure. Scikit-learn is a library written in Python, and it has a lot of helpful APIs for common machine learning applications. So like linear regression, decision trees, what else? Classification type of algorithms, and even like Gaussian processors, or even like I think it might have ARIMA as well for time series modeling.
Hmm. And also, and Keras is a deep learning library, and it's actually a wrapper. So what they've done is that underneath is actually more complicated code. But what they've done is package all that complicated code into simpler functions for people to use, so you can very easily build your own deep learning model out of the box. So the thing about scikit-learn and Keras, I think, is that they have very nice APIs, but as an API, sometimes it may not give you the exact functionality that you are looking for.
For all those of you who are like worried, am I missing out on anything? Don't worry, DataCamp has a module on scikit-learn as well as Keras. So it's towards the end of the module, so don't freak out yet. Okay, let's go back. Will this video be available for viewing later on? Yes, it will be. We'll be uploading it to this channel as well. And on Monday, we'll be sending out a newsletter.
Yes.
Yeah, we'll be sending out a newsletter on a summary of what's going on, plus the link to this video. I received an admin question asking whether we are following the sequence of topics released in the schedule. Yes, we are. You are not required to follow our pace. It's flexible. It's up to you to do whatever you want. Just complete the course within 3 months. Right now, today's session is on Introduction to Python, right? Yeah, it's today's topic we're covering Introduction to Python. As it's our first AMA, we won't be covering too much because we understand some of you guys have only received your DataCamp access, so nothing too difficult just yet, but if you come for the next one, you'll be more technical.
I think we have one more question. How does one get familiar with Python? Going through DataCamp, concept sticks a little bit better, but syntax is quite difficult, even though Python is easy. So how to learn it in an efficient way? Okay, so maybe you want to share some tips, and we can share some.
Nothing beats practice, but what also helped me was to go on to websites like I don't know. Well, there are a lot of websites online that give you like tutorials on how to implement certain features or certain functions, and then reading the code will help you to understand and kind of internalize how you can code in Python a little bit better. And also, if you are into like machine learning competitions, Kaggle, if you go on to kaggle.com, they have sample notebooks, and then you can read their code as well and see if you can understand what they're doing. But at the end of the day, the only way to get better is to write in Python, read the documentation, and then try and internalize it yourself.
Personally, I also felt that if you start your own project with a specific use case, then that motivates you to look for examples online and then to look for data. And the more projects you do, every project you can think of it as a gym rep where you lift one set of weights. So the idea is to do as many projects as possible. So you want to increase the number of reps, which is basically your practice set. And I think reading other people's code actually is really helpful, because Python is a language, and you'll find that different people actually have many different language styles. So if you have a specific use case like natural language processing, and you read 3 different people's ways of tackling an NLP project, that actually helps really get you up to speed on how Python can be used.
Okay, we are receiving some questions from PollEverywhere. Let's hit back there.
Okay.
Any particular question of interest?
I saw something about ARIMA models being used in industry. So the question is time series analysis like ARIMA models still widely used in industry? Short answer is yes. Or is deep learning widely used as well? More and more so. So if you're looking at the healthcare industry, I think in the past it's quite common for people to use ARIMA models, getting a trend and seasonality of data. But then now with like more deep learning processes, you can use like neural networks to do time series predictions as well. And these have been performing, reasonably well and comparable to ARIMA. I guess now you still have the problems of needing a lot of data and maybe needing the computational power to train your sequential learning neural networks. And so it's always good to have to know ARIMA or to know Gaussian processes before you do your deep learning stuff, because as of now they're still quite evenly matched in terms of performance and use.
I hear a lot of terms there, so maybe we can take a step back on explaining to the guys out there, what does ARIMA actually? I myself, I don't know what ARIMA is. Can you tell me what that means?
So it's a study. It is a model used for time series forecasting.
Okay.
And it's an acronym.
An ARIMA model basically tries to use the past to predict the future. And the key assumption within your data, obviously, is that the past is representative of the future. So if you are considering, it sounds hard, but actually that's the gist of what it is.
Okay.
And there are many different flavors of what an ARIMA model is like. You can actually remove the seasonality within something to look at the signal, but it's basically a family of models for analyzing time series.
Okay, cool. Thanks for that. Let's see. Any other questions of interest?
Okay, we have one. If you say from math import pi, what's the difference between that and just saying import math? So when you import for both, actually, you're actually importing the entire math package. So the difference is that if you have from math import pi, then when you actually use the pi function, you can say pi straight away. But if you just do import math, then you want to use the pi function, you have to say where the pi function comes from. So then you have to specify math.pi. That's basically the main difference. But in both cases, you're actually importing the entire math package. So it's not like you save more memory or something with one or the other. Ooh, we have a tricky question. Can we use object class instances in tuples? I don't think so.
Never tried it.
I would say tuples are a container for data structures, which data structures are lists, arrays, dictionaries, data frames. And so you need to put a data structure into a tuple. So I would say no.
Do you have any AI projects to recommend for a beginner? Do you guys have any projects? Or any outlets, any platform? Maybe first I can jump in here. DataCamp has a segment called projects. Maybe you can try your hands at that. They follow a certain, if you complete, let's say, introduction to Python, there's an introduction to Python project that you can do. So you practice the skills that you just learned in the introduction to Python module. I think it's the URL is datacamp.com/projects. So yeah, just go over there and maybe that's a start, but you all can feel free to jump in if you all have any projects for beginners, no?
I would say it's not so much a project recommendation as maybe some ideas on what characteristics you want to look out for. So I would say what I see is a lot of beginners come up with an interesting question, like predicting stock prices. But getting the data is really hard. And so I would say if you can find a nice, clean data set, start with that, and then start to explore the data and think of interesting questions you want to ask of the data. I would say also different people need different levels of structure. So, for example, if you are already a social scientist or a life scientist and you're very accustomed to asking questions, then you can just dive in with a data set and you'll be very good at asking questions. That's a skill not everybody has. So then if you feel that that is something you want to grow, then something more structured like maybe a DataCamp project or a Kaggle competition where the questions are already pretty much laid out for you, that may be a better place to start.
So I have one question for you. Like I get that when I go out to speak to people, they ask, "What do you mean by clean data? What is a clean data set?"
There are many kinds of clean data sets.
Okay.
So the basic, the easiest way to answer that question is that a data set with no missing values, where you use the same method to collect all the data, so everything is consistent. I don't need to find suddenly blanks in some spaces, and then some numbers are integers, and then some numbers are in strings. So that is in terms of the actual file, that's considered a data set that is clean. The other way would be more related to how you collect the data, and that ties into if I collect half the data using a certain method, and then I use a different method, so there might be a bit of contamination if they're not measuring the same things. So to me, that is what we consider clean data.
Another concept about clean data that's actually also quite important if you use R or Pandas or Python is that you want your data to be in a long rectangular form. And so a lot of times when you use Excel, your sheet is wide. But what the kind of data that you normally work with in Excel is not suitable. Clean data also needs to be long. And the technical definition is that every row is an observation. So, for example, if I look out the window, then every time I look out the window, that's one row and I've recorded it into my table. Then what I see outside the window, like number of birds, number of flowers, that is a feature, and then that goes into my columns. So then you end up with a long data set, and then that's actually what you want to be using when you use R or Python. How to determine the structure of DNN? DNN is another acronym. It stands for Deep Neural Network, which is a form of deep learning.
Maybe we shouldn't. Do you think we should cover this question? Was it too early?
Maybe
we can give a summary. Yeah, maybe we can do a summary. I'm sure we'll cover deep learning at some point of time.
Yeah.
So maybe you could give a brief summary and we'll delve deeper in it afterwards. Yes. Okay, yeah.
A brief summary, I would say that traditionally there have been specific structures, but you are seeing more cross-pollination where different structures are being used to solve the same problem, like text. So the boundaries are definitely changing, so stay tuned with that.
Okay, any DataCamp project counts to the requirement. So I mentioned before at the start that if you're not able to achieve the XP, you can achieve the XP by completing DataCamp projects. Yeah.
I can give a very brief answer on the question on about Python not being an end-to-end solution because the engine needs to be interfaced with an application program. So what people usually do is that they use Python to train the models, and then they'll deploy it as an API on the backend, and then you would use some JavaScript or like Swift to call up the API and then get pass the inputs and collect the output from there.
Yes, there's a lot of jargon in that question.
Oh, no.
Mainly for software engineers, I think. So we'll maybe have to leave that to
We'll try and answer all the questions online, but if we're unable to answer you, we'll probably drop all of you an email with all the questions answered after this, probably on Monday. Right? Okay, one interesting question is more industry focused. Aside from programming knowledge, what mathematics and statistics knowledge do you think one should know going into data science?
Surprisingly, I would say linear algebra.
Okay, maybe you can explain to people what linear algebra means.
Okay. If you work with tables and you know what matrices are, then linear algebra is basically taking apart matrices, putting them back together again, multiplying them. That is linear algebra if X is a matrix and B is a matrix. And so if you have an easiest form of a matrix is a table, like again an Excel sheet. And so the way I think about it is a lot of times you're taking apart and putting back the matrix. That's linear algebra.
Got it.
Where can we find nice, clean data sets to try? Kaggle.
Okay,
Too many resources. You also want to try Google BigQuery or even UCI, University of California, Irvine, machine learning repository. But even within Python or R, many packages come with data sets for you to play with. So a lot of times the package author will produce the package and then the data sets within that package allow you to try the package on those data sets.
Okay, so I think we're reaching the end. Do you want to tell us the tool of the day, tool of the week?
Okay, so we thought we'd share very quickly a useful tool that practitioners use, and it's called a Readme. So what is a Readme?
What's a README?
This is not an acronym.
No.
Literally means read me. So it's a file that you have to read that gives a short primer on what to expect when you are using the software or using the code, because sometimes it might be quite intimidating to go into a folder and see like 100 files and you don't know where to start, where to end. So the README is basically where you start.
So it's like the instruction guide to a software? Can you see it that way?
Yeah, pretty much.
Yes, and it's very useful when you're trying to collaborate with people or you want to present your project. The README is the first place people will look. So always include a README with your project.
Okay, cool.
Yeah, so I think that wraps up our first session. Thank you everybody for being here.
Yeah, see you in the next AMA, guys. Bye.
Bye.